of man days annually. This workload doesn't scale for 50,000 CVEs. That's why we decided to remove humans from the critical path. Not to replace them, but to give them back the work they should never have to do manually. But how? The question is how to automate vulnerability prioritization. In a scatter plot, the brightest parts are the densest parts, so there is more vulnerability. You can see the classic methods of prioritization, which is only standard in the CVSS, the x-axis, and the probability is the y-axis. If we look at all of these CVEs, that we will gonna filter the CVEs that are on the CISA cave, which is references to known exploited vulnerability, so the vulnerability exploited in the wild. We got this. We see no such correlation between the CVSS, the PSS, and if the CVE is exploited, which is kind of logical. And that's where we're going to act. That's exactly why we will build our own pipeline, which is a person pipeline.
So our approach is pretty simple. So from raw CVE to actionable reports, 0 human in the loop. 0 human means 0 human error. And this fits perfectly within a streamlined workflow. As an example, you can think of it like your offensive recon chain. For those unfamiliar, it's the chain of automated tools an attacker used to scan, exploit, and exfiltrate data, for example. You don't run Nmap, so a network scanning tool, by hand on 1,500 or 1,000 of hosts. You script, automate, and chain tools. We are doing the same, but on the defensive side. So we built a Python pipeline. So as you can see, there are several modules. Today we will zoom on the 3 modules: enrich, core, and prioritize. So in input we have a list of raw CVE, and as an output we have clear priority colors and recommendation. All without a human needing to interpret anything in between. We eliminate subjective interpretation in moving critical stakeholder from critical paths to decision point. So it's a turnkey solution, and it can be deployed as a CI/CD pipeline or as an internal SaaS. And it all starts with one tool, which is Cyberwatch. So it's an European product, sovereign and air-gap compatible, In our context, which is classified data, defense, aerospace, it's non-negotiable. And most importantly, it's a tool whose core business is vulnerability management. Okay, so let's continue to our process. Our CVE just has been detected. Let's follow it. So let's begin, Cyberwatch can scan one of our assets on one of our servers, for example. We have a fresh CVE, so CVE 2025-53-52-1. So it's regarding F5 Big PIPM. There is some vectors. We won't go into detail regarding this, but it's information regarding the vulnerability. So we have a CVE number, a base CVSS score, which is 9.8. The max is 10, so it's critical one. So on paper, it's panic mode. 9.8 network, no out, full impact. Everyone freak out. But is it really urgent? Is someone exploiting it? Is there a public exploit available? Is our server even accessible from the network? At this stage, we don't know, and that's exactly why base CVSS score alone isn't enough. We need context, and that's the next module job.
Let's take a look at our snippets of the enrichment module, which is a Python pipeline. Actually, we only have a CVE code, her score, and that's all. And we are gonna dump some databases to have more data for this vulnerability. The first data we're looking for is the data from the MITRE, like the CAPEC, which is the attack pattern, the CWE, which is the weakness the vulnerability use, and its place on the MITRE TCK matrix. So let's get a look for the CVE. We're looking at the CWE 121, which is a Stack Overflow, and a certain attack pattern. The attack pattern is useful because when you have 10,000 soldiers walking into the same bridge, you will not shoot on any soldiers, just explode the bridge. So looking at the KP can be useful when you have a lot of vulnerability. Next, we're looking like you, when you do a lab and Box, we will look at exploit.db, or exploit on GitHub. We'll search for any exploit on the CVE, because if any exploit is published, the EPSS of the CVE will explode. At the time of the presentation, there is no exploit for this CVE on Big IP, but it has been functional because an enterprise has been pawned by the CVE. We know this due to the next part, which is enrichment part of the references. And we're looking at references like dictionary for the CISAKEV, like we saw before for the non-exploited vulnerability, and the CVE has been used. We're also looking at French cert right now, but we can look at many certs as we want. So now we're not looking only at a score and a CVE, we're looking at the modus operandi, how to use a vulnerability, with what tools, and that's all. The more data we have, the more precise our analysis can be. Well, we enriched it, but we need to contextualize it. To do so, we're looking at the vectors. I will not explain every of the vectors, but this CVE, as Paul said, is a network one. So it can be used from anywhere in the world if your load balancer, because it's a CVE that touch load balancing, if the load balancer is available into the network. First of all, we will add temporal factors, which is, as I said, if the exploitability is published, if an exploit is published on GitHub or in exploit.db, if the vulnerability is correctly referenced in any dictionary, and if there is a fix. Today, with this vulnerability, Big IP released an official fix. The CVE is well documented with the French certification process and the CISAKEV. And there is a functional exploit, but not available for everyone. So it will lower our score. It will go from 9.8 to 9.1. Then we will add surface vectors, which is how to attack our load balancer. If we take an example of a load balancer inside of Airbus, which will be behind a firewall, there is no network direct access to this load balancing. Thank you, Sally. There is no direct access to this load balancer because it's behind a firewall, so it will be adjacent to the firewall. I'll just remove it, sorry. Sorry, Sally. Because it's behind a firewall, especially behind a VPN, we will add some privilege requirement and some complexity to access to the load balancer. So again, it will be the best part that will lower the score and contextualize the vulnerability. Then we will add some business logic because we are in Airbus, so we have some military machines, and it will add some business logic because we will need a high availability, especially for a load balancer with critical application. High integrity, because if you pawn a load balancer, you can maybe do man-in-the-middle attack. And low confidentiality, because the load balancer should use only layer 4 and layer 7, so for the confidentiality part, it matters less. If we take a look back to the graphic, to the plotted graphic, and if we apply, we'll just all of the CVE, if we apply this logic, normally each CVE has a special logic of vectors, but let's take a look at only those vectors that I showed you. It will went to this. As you may see, it's a bit laggy, but all that you should see is that a lot of CVE, when lowered in criticity, so this is the x-axis, the criticity part, but some of the CVE, like this one, but we didn't clearly see this, which is this one, didn't move at all, because all of the surface vectors were already applied to the CVE, so this one is critical less than the previous ones that were critical. That's all.
Let's apply this to our CVE. So we are talking about the same CVE, the same product, which is F5 Big IP IPM. on two load balancers in our infrastructure. We have two completely different scores. We are using the same pipeline, the same logic, it's the same CVE, the network zone is the variable, and as you can see, it changed everything. You in pen testing, you know this intuitively. An RCE, so remote code execution, on a machine you can reach from your laptop, it's not the same as an execution, RCE. On a machine you can only reach after going through 3 network layers or firewall. So we formalize that intuition into a scoring model.
But we need a single KPI, because at the end of the pipeline, we need to simplify all of this process. So we're gonna try to, once we have enriched the vulnerability and contextualize it, we will try to process to a single, unique scoring system, which will be here the threat level scoring system. As I said, we've enriched the vulnerability, we contextualize it, but once that we have much more information, we can then now make the analysis, which is a basic sum of weight. It's a bit simplified for this presentation. But we will look at all of the objects we have now, and we will do a basic sum of weight with different weight from different program, or an hospital can have different methods at a military machine. This is a default weight we use for a baseline, but we can look at active threat potential with SSVC, the delta between CVSS, the probability of exploitation, GitHub exploit. We can have basic cert watching for development purpose. And this threat level will be a new scoring system, additionally to the CVSS and the EPSS. You can also inject custom signals. There we use the French certs, but you can use the European ones, the Dutch one, as you want. The thumb doesn't care where the signal comes from. Let's go back to the graphic again. With 2 axes, but now we have a third one. It's loading. Nice. Remove this one, and now we will calculate the threat level that we just did for all of this vulnerability. We get this one. So you can see the 3 axes, the criticity on the x-axis, the probability on the y-axis, and the threat level that we calculate on the z-axis. To look at the both vulnerability we've seen before, a big IP is there. Try to zoom on it. Something like there. The Fortinet vulnerability, we will see just after, is there. Copy fail just the previous week is there. And obviously, log4shell is there. If we look at the filter that we used before, the CISA part, so we will just take a look from above to clearly see the threat level axis. And we'll focus only on the CVEs that are known to be exploited. We clearly see the correlation and the accuracy of our system. To be honest, I removed the part that we've seen before on the threat level, where there is a part to sum the weight of the CISA cave, because it will add some consanguinity. It's not. You can trust me, or not. So we see such a clear correlation between our system and the vulnerabilities that are known to be exploited, and we know can make the reports. But the threat level system is a bit obfuscated, so we will traduce it to a new priority system, which is basically this one. We will just zoom on the criticalest CVE, the red one, which will be P1 to have a single KPI, then P2, the orange part, P3 for the yellow part, and so on. Let's take a look again at the filter. We clearly see our correlation. Normally, with the threat level I presented you, we patch from P1 to P4. P1 and P2 are really urgent. P3 are less urgent, but we recommend an immediate action, and P4 too, which it's this. Bon, tant pis. Let's take a look of comparing two vulnerability, which is the big IP one and the Fortinet one we just saw.
Yeah, so, sorry, let's apply threat level to our running threat vulnerabilities of big APM you have on the left, and compare it with the second one that look far less dangerous on paper on the right, sorry. So it's regarding Fortinet. So on the left, it's regarding big IP APM. As you know, the base CVSS score is 9.8 and tagged as critical. But the surface constraints drastically reduce real-world reach. So because the attack vector is adjacent and authentication is required. So our contextualized or compute score is 5.9, you can see in gray. Then we calculate the threat level. So the CVEs in the CISA cave and CertFR, exploit maturity is POC, and several other factors. So we obtain a threat level of 69. 69 means prioritize, but don't drop everything in order to address it. The other one is regarding Fortinet, so you will see on the right. So the vulnerability allows an authenticated attacker to execute unauthorized code of the underlying system by sending crafted HTTP request or CLI command. The base CVSS score is 7.2, tagged as high, so less than the other one. So it looks less dangerous, but the environment amplifies it. Our contextualized CVSS rise to 7.7. And then after our threat level, we get a score of 77, which is higher than the other one. So the CVSS, the base CVSS score, rank big IP vulnerability as the winner. But in reality, our threat level reverses the verdict. The pipeline identifies the difference where raw CVSS does not. So everything we just showed is configurable. Some adjustment and tuning can be made. CVSS and IPSS threshold are parameters. So on ultra-sensitive environment, we lower threshold, become more paranoid. On the other side, on development or test environment, we raise them in order to avoid noises and false positive. The score column is also used as a choice. Base CVSS for team or project wanting standards. Temporal score for those wanting to integrate threat evolution. And computed score on contextualized score, for those wanting full contextualized vision. So team or project can modify these values according to their need without endless meeting. The decision stakeholder understands the report as well as the security engineer, and the output data is consumable by everyone. P1 red, not good. P9 blue, seems okay. So it's decision making at a glance.
So to conclude, this is our pipeline output, which will be Excel reports. Let's take a look at the first page. There is different page for different technicality, but this page is for the decision-making point. We will gonna see all of the CVE we just looked through the talk. The critical last part is the Fortinet one because it obviously touches firewall. Then we have our two load balancer with the big IP. We can see copy fail, the 2026 one. And you can see that with at a single glance, the decision maker can see which decision he have to do with the priority part. That's the thing on the right. To P1, P2, P3, we patch from P1 to P4 with a critical action from P1 to P2. This is sorted by threat level, so it's really simple and easy to read. But there is different pages to help through the mitigation part with the attack pattern part, and so on. So this is the pipeline purpose. Volume become value, and noise becomes signal. Having all of this as a Python pipeline can help us with the CI/CD parts, with the source parts, and with diagrams if you know how to manipulate data frame in Python.
So to summarize with some key points, so we have sovereignty, Cyberwatch is European, our scripts are internal, we control the entire chain, and in a defense context, it's non-negotiable. It's fully automated, So the pipeline run alone, it's reproducible, scalable, and configurable. We are crossing multiple sources. We trust no single source. We are cross-referencing, and the CVE flagged by multiple sources is a very strong signal. We contextualize. We saw that raw CVSS score means nothing without context. We adjust based on attack surface, exploit maturity, available patch. And 9.8 vulnerability can become a 5.9, and 5.9 can still be a priority 1. And we always threat active, we always want active threat, always go first, so we are not drawing in accumulation of medium or weak signal. Thank you for your time.
Thank you. Question. A lot of questions.
Yes, thank you for your talk. It was quite interesting. I understood pretty well how you automate parsing CVE, browsing different sources for exploits, CISA, GitHub, and everything. But I did not really understand how do you inject like your CMDB? How do you know how many Fortinets do you have in which zone? LAN, DMZ, connected to the internet, not connected to the internet. And for me, it seems to be the most important part. And I did not really understood how you inject that data into your pipelines.
Yeah, it was when we told you about the two pipeline. The pipeline you're talking about is the scan one. For the scan one, we will go through our entire project, which we scan with different tools. There is two scan tools, one custom one, which is Lea for those who knows, which is the part where we're gonna use basic tools like cdgen, Trivi to scan Docker images, GitHub repo, and so on, and custom tools that we do at Airbus. And Cyberwatch have tools to scan our machine, our informatic part. After this scan, we will ask for the project to make a meet with us to talk about the business logic, the vectors we seen just after. This is a common discussion with the project to add their surface logic, their business logic, and so on. And then next, we will use the matching of Cyberwatch for the vulnerability. And then we have raw data with all of the vulnerability for Fortinet if there is a firewall Fortinet in their system. We'll see if they use Log4j for Minecraft server, if they have one. I doubt so. And then we have the raw output. And then this raw output is sent to the analysis pipeline. That is the purpose of this talk with the three modules, the enrichment parts, the scoring part, and the prioritization parts. But the scan pipeline is not in this talk. But yes, it's really, really important, and it is precisely what I'm working on. Actually, it's on the scannes part.
Hello, thanks for the call. Yeah. So there have been some kind of issues on CVE side with a lot of CVs that were not enriched or even written in time. So a lot of dependencies toward American organizations. So how do you aim to tackle that dependency to be even more sovereign?
Yes, it was a discussion from the last year with thanks to Trump, the politics here. But yes, if the NVD will be cutting off their money, they will know such common baseline for vulnerability scanning. But we use on the same slide, we use Cyberwatch, and this software could be able to reproduce what the NVD is currently doing, because the NVD will just try to merge all of the data from different producers. But Cyberwatch is scraping the data directory from the editor. So like there is in in discussion with Storm Shield, with SUSE. They will scrap for any security pages. They will scrap it with a scrapper, and then will reference all of the CVE. And they will also look at the NVD database. If there is no vulnerability database, we will look at this part, which is the matching part. All of the parts you see, except of Sadi, please. If tomorrow there is no NVD, we will just move those two parts, this part especially, which is the matching part, because we will maybe no more use Cyberwatch, because we will maybe use our own CVE databases. We will make our own. And then if we don't use Cyberwatch, we'll maybe switch for our inventory system. But all of the next module you can see, the scan part, the output part, and all of the analysis pipeline is our own pipeline. So we admit that the only weakness is these two parts. We are working on the inventory, as I said. But next, we will maybe work on the matching part, where we are maybe going to do the NVD part alone inside of Airbus.
Yes, thank you for the talk. As you are using you are adjusting the scoring based on the existing exploit for vulnerability. Today, the proof of concept, the exploit for vulnerabilities are coming faster and faster. How do you maintain your scoring within your tool? That's probably the question.
We will just move the weight of the sum for the CVSS part. As you may see, our threat level system, the CVSS is a bit high in the weighted sum, but it can be. The CVSS is really a system that is pretty weak. So the sum the weight we're gonna put through the signals will maybe get lowered the less impactant it will become. If we see no such correlation, it's these pages. If we don't see such a clear correlation with the CVSS by our pipeline, we will maybe lower the weight of the CVSS.
Yeah, the idea is to adapt and to adjust the threshold in order to, if it seems like there is too much weight on the CVSS, we can adjust and see if it's doing a better job, or we have better output that we expect as our matching our security level.
The CVSS part is really for the contextualization of the vulnerability. For example, of this one, it was a vulnerability. It was the difference between a vulnerability impacted a load balancer behind a firewall, which was critical with the CVSS, but more critical that the CVE impacting Fortinet. But we've seen that the Fortinet one gets increased at the threat level because of the priority inversion. If we remove the part or lower the part of the CVSS contextualization, we will use another system to contextualize the CVE. And we lied a bit because the contextualization part, when all of the CVE on a single process, in the real time, it's not it. All of the CVE are calculated one by one, not every one in a single time.
Thank you. We're going to have to stop there.
Okay,
Thank you for the
thanks a lot.
presentation.
Thank you.
The next presentation will also be in Visio, sorry, so we have to start the Visio.